Hey, welcome back to Check This Out Mathematics. And in these series of videos, we are doing some lessons on logarithms. And so we've been talking about this overall concept. Where do logarithms come from? Well, the idea is that if we have a base raised to a power or a base raised to an exponent and we get a result, that we can turn that into a logarithmic expression where the log base b of x equals n. So here, the base, this is the base here on the exponential expression, and this is the base here on the logarithmic expression. And so when we say b to the n equals x, that means log base b of x equals n. And n is the exponent here, and n is the exponent here, and that makes the logarithmic expression an exponent as well. And when we raise a number to a power, when we raise a base to a power, we get a result. And that result is thought of as the argument of the logarithm. So log base b of x. What are we discussing? What is our discussion item? The x, the log of x. And so that's our argument. Okay, the log base b of x equals n. Okay, and this is what we call our round trip. When we go from an exponential expression to a logarithmic expression, okay, we can come from the logarithmic expression back to the exponential expression by following this around trip. So when we have log base b of x equals n, we say b to the n is x, and it takes us back to what we started with. And isn't that what a round trip is anyway? Go on vacation, take a round trip, come back to where we started. Okay? All right. And now we also have been talking about properties of exponents and logarithms. So let's look at this list of properties of exponents and logarithms. Here we have log base b of b is 1. And that's because b to the first is b. Okay, so the logarithm is asking, what is the power that makes b become b? Well, it's the first power that makes b become b. Okay, let's write that down. What is a logarithm asking? Okay, log is asking what is the power. Okay, that's what a logarithm is doing. It's asking what is the power. Okay, so what is the power that makes b become x? Well, the power that makes b become x is n. b to the n is x. And so when the log is saying, well, what's the power that makes b become x? Well, it must be n, because b to the n equals x. Okay. And so now, these are all based upon that round trip. The log base b of b is 1, because b to the first is b. And the log base b of b to the n is n, because b to the n is b to the n. What is the power that makes b become b to the n power? Well, I bet it's the n power that makes b become b to the n power. That n power right there. Can't argue with that. Okay. so there's our round trip. Log base b of b to the n is n, because b to the n is b to the n. And here, log base b of 1 over b. Well, that's -1. What's the power that makes b become 1 over b? The -1 power. So b to the -1 is 1 over b, just like it says here. And that's what we're talking about here. If you want a -1 power, what does a -1 power do? It makes 2 become a fraction, 1/2. And so that's what a negative exponent does. It takes the base and makes it 1 over that base. Okay, and then if you're asking what power of b makes 1 over b to the n, well, just like here, b to the n is x. Okay, and then 1 over b to the n, how do we get a fraction? Well, we need to raise it to the -n power to get a fraction. Okay, so b to the -n is 1 over b to the n. All right, now we have a few more properties of logarithms and exponents that we talked about previously. Log base b of 1 is 0. Okay, remember, b to the 0 is 1. Okay, just like we had on this illustration here. 2 to the 0 is 1. Okay, and so what power of b makes 1? Well, it's the 0th power of b that makes 1. So log base b of 1 is 0. Log base b, how does b become the square root of b? Well, it's the 1/2 power. Talked about that on a previous video. So b to the 1/2 is b. And then if you don't want just the square root, you want some nth root. Okay, well then you say b to the 1 over n is the nth root of b. Okay, and then here's our interesting power that is also about the round trip. Let's show that round trip now again. So b to the 0 is 1, and b to the 1/2 is the square root of b, and b to the 1 over n is the nth root of b. Okay, b to the 0 is 1, b to the 1/2 is the square root of b, b to the 1 over n is the nth root of b. And here, let's imagine that we took b and we raised it to the log base b of x. Okay, this is a true statement that the log base b of x is equal to the log base b of x. It's true, they're the same. Okay, but just like on this round trip, we can go from b around here and come back to the argument. Okay, and so if we took b and we raised it to the log base b of x, as it shows right here, the b is raised to log base b of x. Well then, as you come back around, you must get x. So b to the log base b of x is x. Okay? You have to believe that the log base b of x is an exponent. That's what we said around here. The log base b of x is an exponent. N is an exponent. N is an exponent. So the log base b of x, which is equal to an exponent, must be an exponent. And so if we take b and we raise it to the log base b of x, perfectly good exponent, we get x. Now, Mr. Donald, I don't get that. Okay, well, let's understand it here. You see, the log base b of x is a power. It's an exponent. Okay? So when we take b and we raise it to the n power, we get x. And so that n power is also thought of as the log base b of x. So instead of raising it to the n power, we could raise it to the log base b of x power. So just imagine that instead of n here, we substitute what n is equal to, log base b of x. And so now this would read b raised to the log base b of x is x. Okay? There is a power, n, that makes b become x. How does b become x? Well, you need the n power for b to become x. So there is a power that makes b become x. That's n. And when we take b and we raise it to the power that makes b become x, well, we get x. Listen to that. There is a power that makes b become x. And so we're raising b to the power that makes b become x. And you know what? It better become x. There is a power that makes b become x. And we're raising b to the power that makes b become x. And so what happens to b? It becomes x. Can't argue with that. All right. And now then, there are some more properties of logarithms. And we're going to get to these properties later on. This is called the change of base property. That if you have a base b and you'd rather write it as base a, well, you can do that. The log base b of x is the same as the log base a of x, as long as you remember that it wasn't base a to begin with, it was base b. Okay. And then here's another property of logarithms, that if you have a logarithm up here as your exponent, so you have a raised to the log base b of c, that the c can come down and the a can jump up. Look at that. Logarithms are like superpowers. I mean, superheroes. They have superhuman powers. I mean, how can this a jump up to a c there, and this c jump up to the a? I mean, that's like a superpower. Okay? And here's log base b of a. You want that a to jump down and that b to jump up? Well, just put 1 over. And then you have log base a of b. So before you had log base b of a, and if you want log base a of b, well, that just goes under there. 1 over the log base a of b is the same as the log base b of a. Amazing. And you know, if you even have this crazy idea that the base is b to the a power, and so log of the base b to the a power of c is the same as the log base b of the log of the base b of c to the 1 over a. So if you have an exponent down here where the base is, you can jump it up as a root, 1 over a. Superpowers of logarithms. Yeah, logarithms have powers, because logarithms are exponents. They must have powers. Okay. All right. We're going to talk about those later. Okay. All right. So now, let's talk about some properties of exponents that we remember. If you have b to the n times b to the p. Well, what happens when you multiply? You add those exponents. Okay, when the bases are the same, you add the exponents. Okay? And when the bases are the same, in this arrangement, you can divide the exponents. You can subtract the exponents. Okay, so when you're dividing and the bases are the same, then you can subtract your exponents. Okay, let's remember those ideas in context. If I have x to the third and x to the second, well, wouldn't I just add those and get x to the fifth here? Yeah, if I have 3 x's and 2 more x's, well then don't I have a total of 5 x's? Yeah, I'm just adding those exponents. And then if I have 5 x's and I divide out 2 of them, I can subtract those and get back to x to the third. Okay, so when I'm dividing and the bases are the same, then I subtract the exponents. 5 x's, divide out 2 of the x's, leaves me with 3 of the x's. Okay, and let's remember one more property here. That if we have x and we have to the second and then we have to the fourth, x to the second then raised to the fourth power. If we have a power to a power, we multiply those powers. 2 times 4. And that's x equals, that's x to the 8th. Okay? So when we have a power to a power, we multiply the powers. And we get x to the 8th here. You see, this is saying we have x to the second, and another x to the second, and another x to the second, and another x to the second. So 2 x's, 4 x's, 6 x's, 8 x's. Okay? 2 x's, 2 more x's, 2 more x's, and 2 more x's. Okay? And so that makes 2, 4, 6, 8 x's. Okay? And so what does that look like in our properties here? Well, if we have b to the n to the p here, we have a power to a power, then we multiply those powers. Okay? We multiply the powers. Power to a power, we multiply them. Now these are properties of exponents. And oh, wait a second, we have a new word for exponents. It's a logarithm. New word for exponents. It's called a logarithm. A logarithm is an exponent. And so if these are properties of exponents, well, you must have properties of logarithms, don't you think? Okay. So if we have log of a times b. Okay, so here we're multiplying. And what do we do when we multiply? We add the exponents. Okay, so when we're multiplying, we add the exponents. And this is the new high fashion exponent. It's called a logarithm. Okay, so here's an exponent. We add this exponent to the other exponent. Okay. All right. And then if we have log base a log of a over b, here we are dividing. And so what do we do with the exponents when we divide? We subtract. So we say log of a minus log of b. Okay, so when we're multiplying, we add the exponents. And each of these are exponents. The log of A is an exponent. The log of B is an exponent. Okay? And when we're dividing, well, that means we subtract the exponents. And these are exponents. Okay? And then, if we have a power to a power, how does that look like? Well, we have log of A to the P. Okay, so when we have a power to a power, now isn't it that the log of A is an exponent? Okay, and here we have a power. Okay, so the log of A is an exponent, and there's another exponent right here. So this is a power to a power. A power to a power. And what do we do when we have a power to a power? We multiply the powers. So we would say the log of A, that's one of our powers, and we would multiply it times the other power, P. Okay? So when we have a power to a power, we multiply the powers. P is the power, and the log of A is the other power. So logarithms have the property that they can bring exponents down in front. Okay? That's called the high five for logarithms. Okay, who taught you this, Mr. Doll? I did. It's a high five. Okay? So when you greet somebody, it's up top, right? And then when you might say, I'll see you later, you might say down below. Up top and down below. And so here, up top, or actually down in front. Down in front, that's right. Up top and down in front. Up top and down in front. And so when you have up top, it goes down in front. And when it's down in front, it can go back up top. High five for logarithms. Okay, good stuff. Okay. All right. So those are some, we have all these properties of logarithms here. Okay. Let's switch them. Put these in this hand and these in this hand. There we go. Okay, we have these properties for logarithms here. And then we have these properties of exponents. If we multiply, we add the exponents. If we divide, we subtract the exponents. And if we have a power to a power, we multiply the powers. And same thing for logarithms. If we're multiplying, we add the exponents. If we're dividing, we subtract the exponents. And if we have a power to a power, we multiply those powers. Okay. All right, now, in the next video, we're going to do some examples of all these good properties, okay? Working some problems. Okay, but you'll have to tune in next time to check this out with mathematics and give these videos a thumbs up and subscribe to my channel and oh yeah, comments down below. We like comments. All right. Thank you, Mr. Donald, signing off for now.